Sandia National Labs has had an earth sciences program since the inception of the institution. And we've added on to that a nuclear waste management set of activities since the 1970s. This 50-year history has allowed us to contribute to the Yucca Mountain project, to the waste isolation pilot plant, and other repository and nuclear waste management programs. The basic skill set that we bring to this is to connect basic earth sciences with a set of systems analysis tools, and then being able to understand the risk analysis and be able to tell that in a cohesive narrative to the regulatory communities in the federal and state level.
When I first came to Sandia, I was it. There weren't any other geoscientists active on a roll. But that, as you know, it did change rapidly with the years. And it's because the projects that Sandia fell into or developed or convinced DOE should be pursued required a geotechnical sort of background from some of the staff.
Sandia had a great reputation. They still do. But then, of course, I thought they were godlike. That's why I chose to work for Sandia and was lucky enough to be hired.
I came into a group used to be called the Nuclear Waste Management Systems Division, but it was established in support of the NRC, the Nuclear Regulatory Commission. So the main job of that group, which started in the mid-70s, here around 76, 77, was to help the NRC develop their tools and approaches and methodologies for being able to license a nuclear waste repository.
About the time in late 74 when things changed again with waste management back at headquarters. They came looking for an in-house laboratory, in-state laboratory, to take over the WIPP activities. And they came to Sandia because Sandia was an engineering lab, and engineering was a job that remained to be done because they had a site, and all we had to do that involved any aspect of geology was drill 2 more holes and take the core, which we did and discovered it wasn't a site. So we went on from there and developed into quite a program.
This was 1989, 1990, so 15 years, yeah. And WIPP was just in a transition from being a research project to being a licensing project. Certification is the EPA term, and then eventually an operating facility. But that transition from a research project to a regulatory project was one that Sandia struggled with, and I was fortunate to come in at just the right time because that's what I really wanted to work on, was the applied aspects of how do you get a site through the regulatory process.
So, you know, when we're doing a risk assessment, there are basically 3 questions. It's called the risk triplet. Is what can happen, how likely it is to happen, and what are the consequences if it happens. Sandia added a 4th question to that, which is how reliable is the information, because of all the uncertainties associated with that. And we were doing a lot of the development of those, you know, the Sandia scenario methodology, which became internationally recognized.
The largest issue we faced was actually answering the question of, do we know enough? It's inherent in decision making, which is what regulations are all about, that you have to make decisions with incomplete knowledge. You just have to. And whereas research science wants to learn as much more as it can. So the challenge we were faced with was, what research do we not need to be doing, rather than what research do we need to be doing? What can we go to the customer, the DOE, and say, you're done here. You can take this one to the EPA and make them decide yes or no on it.
One of the largest efforts by Sandia has to do with what they call performance assessment. And performance assessment is a set of probability codes, calculations of things that happen based on certain evolutions of the underground, certain scenarios playing out, called performance assessment.
It helps to think of it as in terms of uncertainty. It's an uncertainty analysis, by which I mean that what we do have to do, and we have to do it well, is justify the range of uncertainty that we're going in with. We don't know if the answer is, we certainly don't know an answer to any question exactly, but we know it within some range and some distribution of possible outcomes within that range. But if we can show that within that entire range of uncertainty, it doesn't matter. The site is good enough, the site is safe, then we're good to go in that. That same reasoning, you can use it everywhere. Phrase the question of how confident are we in what we know, what are the ranges in what we know, and can we live with that uncertainty in what we present to a decision maker. Last thing we wanted them to do was to go ahead with a regulatory case that was poorly founded. And it was up to us to make sure they didn't do that. They were really pleased to discover that there was a team at Sandia that had a way to get there for them. DOE got its final certification on WIPP in May of 1998.
So there was good energy, bright-looking future. We had the license, we had the certificate to go forward, and so on.
Our work with the waste isolation pilot plant, which began in the mid-70s, provided a foundation of earth science and risk assessment capabilities that then established Sandia as a contributor for the Yucca Mountain project.
Why'd you go to Yucca Mountain? Well, because Sandia provides exceptional service in the national interest. This job is put to bed. Where's the next problem? And no, you didn't have to look very far, because the Yucca Mountain project was in deep trouble.
First of all, technically it's a much more complicated problem because mostly because of the heat source. That waste generates a lot of heat, and so that changes the chemistry, it changes the hydrology, it changes the response of the rock. But it was also more complicated institutionally. The DOE had historically interacted directly with half a dozen different national laboratories, and the M&O contractor was much larger and more powerful and less focused than the WIPP contractor, Westinghouse, in those days.
The Nuclear Waste Policy Act, 1987, and the commitment by the DOE was that they would accept civilian waste by 1998. 1998. In 2004, they had not even submitted a license application for construction. Okay, you can do the arithmetic. They were roughly about 20 years behind schedule.
And in 2006, Sandia, and it was Andrew Orell was the lead figure in this. Actually started in 2005. Put together a proposal to the DOE to have Sandia take on a lead laboratory role, analogous to the one we had on WIPP. So instead of DOE, instead of having multiple national laboratories reporting dysfunctionally to an M&O, there would be one national laboratory reporting directly to DOE. And DOE accepted the proposal. I mean, they put it back out for bid to all the labs and then awarded that role to Sandia in 2006.
So we used the regulation as the framework for start developing the license application. Then we started analyzing, okay, what are the key messages that we want to send under each one of these requirements, and how does it tie together?
It was a challenge. It was a challenge to make the argument that it's safe. It doesn't mean it wasn't safe, it's just that it has an awful lot of moving parts you have to explain. WIPP is a simpler case to explain. People intuitively understand that that salt is impermeable. You show them a piece of salt and say, look, as long as it stays dry, or at least dry from respect to fresh water, it doesn't dissolve, nothing gets through it. People understand that. Yucca Mountain, it's a porous rock. It's obvious water does move through it. It's a system that relies on performance of metal over very long periods of time. People are suspicious of that, and it's a harder case to make. We had a year and a half to get this license application in, and we made it. It was good, remarkable. 8,000-page license application with 30 or 40,000 pages of supporting technical documents, and a year and a half.
Nuclear Regulatory Commission had the opportunity to review the application, and to the extent that they reviewed it, it was spot on, 98%. You know, there are always things, but it was an adequate application. I'm not saying it was perfect, not even saying it was superlative or good. Adequate. It met the requirements of 10 CFR Part 63 and New Reg 1804. That's what you do. You meet those requirements.
It's a struggle because since Yucca Mountain was suspended in 2010 by congressional action, it was defunded. And since then, the DOE has kept an R&D program going, which in both storage, transportation, and disposal of spent fuel and high-level waste. We're doing generic research on hypothetical sites. And part of the purpose of that is to keep the team ready so that if and when, and I hope it's a when, not an if, we have national policy, we'll be ready to go. The U.S. is a big country. We have lots of options on geology. And so when we have authorization to go ahead and look, we will have a well-trained team and ready to go on any, whatever type of rock appears to be politically plausible, possible, we'll go for it. Go back to the early years on WIPP when the Sandia team, I mean, it would be inappropriate not to acknowledge Wendell Wirt's just astonishingly important role in that. And he's an earth scientist first, he personally left a lasting culture on WIPP that I'm an heir to, and generations beyond me, whether they recognize or not, they'll be an heir to the culture he created. That's why I think it's important that we have some continuity. We don't need the same people. In fact, it's obvious that new people will come along and find new ways to solve old problems, and that's good. But it's that culture of how to put it in context that Sandia does so well. But the team, the next generation, they get it, and the culture will survive.
Nuclear waste management is the type of problem that requires decades to potentially hundreds of years to fully resolve. As a consequence, an institution like Sandia has been dedicated over at least 50 years to maintaining these capabilities, and we anticipate that this kind of skill set will be essential for another equally long period of time.